This is our video for the 1.4 section notes and examples. Starting at the beginning here, we got some definitions. And the first definition is a polygon. And poly meaning many, and then polygon is a many-sided shape. So we say that this is a closed figure formed by 3 or more line segments. We can't have a closed shape without at least 3 lines. And we call those line segments the sides of the polygon. And we see that over here. This is a side of the polygon, and specifically that is side BC. The point where 2 sides comes together, we call that the vertex. So the corners, the points where those 2 sides come together are called it's called a single vertex or multiple vertices. So this is, again, this is a closed figure, and if it was not a closed figure, it would look something like this. Notice how these 2 ends don't meet. That's what would be open, and we don't generally talk about figures that look like that, but we could. The next idea is this idea of convex versus concave. And we say that a polygon is convex if, or a polygon is convex when, no line that contains a side of the polygon contains a point on the interior of the polygon. And that's a really long, kind of complicated sounding mathy definition, but we can break this down. So we're thinking about convex, and we say it is convex when no line that contains a side of the polygon. So we're thinking about lines that would contain a side. So for example, this would be a line, and it contains one of the sides of the polygon. So if none of these lines also contain a point inside the polygon, it is considered convex. So notice none of these lines that contain the sides go through the shape. If it is not convex, we call it concave. And here's our example of concave, where we can see this side of the polygon, if the line that contained that side is going to go through the shape. And this one actually will as well. I always think of concave as caved in, like if this were a shape that had a side there and somebody came and pushed that side in, that's concave. Moving on to number 3, the number of sides determines the name of a polygon. So this table here kind of shows us the different names of polygons based on how many sides that they have. So I would take a second, kind of familiarize yourself with this list. The only ones I really need you to know are probably 3 through 6 and number 8. These are probably ones that you have heard before. Quadrilateral is kind of an overarching term. So within that we have, squares, rectangles, parallelograms, things like that. But those are all considered quadrilaterals. At the bottom, this just says n-gon. So for any number n, we could call it a 15-gon, a 30-gon, however many sides it has. Moving on to perimeter and area. These are our different equations for these things. So triangle, perimeter is going to be just all of the sides added up. So A plus B plus C. So side A plus the length of side B plus the length of side C. So if we need to find the perimeter, you need to find the lengths of all of those sides and then add them up. The equation for area is 1/2 base times height. You will often see me write it as base times height divided by 2, and that does mean the exact same thing. So either way you prefer to do that is fine. Moving on to a square, just some different notation than you might normally see. So perimeter is 4 times s, where s is a side length. And that makes sense with a square, because if all the sides are the same length, 4 of them would be the perimeter. And notice our notation that we saw earlier too. So the single line through each of these sides tells us that all of those are the same length. And notice that same notation in a rectangle. These two are the same length, and when we've got 2 lines, that tells me that those sides are also the same as each other. Parallelogram. Perimeter is the same, even though it doesn't give us an equation. And we might not think about this, but the area is the same basically as a rectangle, right? If we were to kind of just cut this off and go straight up, base times height. And we can think of that if we were to kind of cut this edge off. If I were to take that piece, pull it off, and then move it over here, it would really form a rectangle. So it makes sense that we could use that basically same equation to find the area. So what I'm asking, I would ask you to try. In class, we had students just try this problem on their own. First, finding perimeter of this triangle, and then the second part will be area. So for perimeter, anytime that we have a straight line, notice that I've got whole boxes here, 1, 2, 3, 4, 5, 6, 7, 8. Anytime a line is horizontal, or if it were vertical, you can just count. We don't have to do anything fancy for that. I don't expect you to do any sort of equations. We can just count that length as 8. However, anytime we have a diagonal, you do have to use the distance formula, the distance equation. I cannot count. I can't count across the diagonals of the box. That does not work. So for this length df, I would use points D and points F and find that length, and the same here. And then once I get those 3 lengths, I'm just going to add them up, and that will be my perimeter. So I'm going to go through this fairly quickly because we've talked about distance quite a bit. If you need more instruction on the distance equation, I believe that was section 1.3. I would go back and watch that video. So df, if I've got square root of x2 minus x1, I've got 1 minus negative 4 squared plus 3 minus negative 3 squared. 1 minus negative 4 is 5. 3 minus negative 3 is 6. This is 25 plus 36, which is 61. And if the square root of 61, since we're going to need to add these numbers together, we're going to want to put this into a calculator and get a number out. So I will calculate that in just 1 second. DE is the other side that we need. EF we already know. So square root of EF, I've got 4 minus 1. And then negative 3 minus 3 squared. Square root of 3 squared plus 6 squared, which is 9 plus 36. Square root of 45. So, let me calculate those numbers real quick. I did not have that handy ahead of time. So the square root of 61, square root of 61 is approximately 7.81. Got a whole lot more digits, but I normally just round to 2 when we're using a calculation like this. And then the square root of 45 is 6.71 approximately. So those are my 2 other sides, and to get the perimeter, I just add all of those up. So 7.81, 6.71, plus that bottom side is a whole number 8, and I believe we get 22.52 for the total perimeter. Moving on to area, final thing on here is thinking about the area of this triangle. And when we think about the area of a triangle, we said that the equation is base times height divided by 2. My base, you always want to find a nice straight line that you can count. Almost always you will have one that's nice and straight, at least in this section of our text. So the base in this case would be 8, and for the height we need to go straight up to that other point. So 90 degrees straight up. And in this case we can just count that distance as well. So the base is 8, the height is here, so that's 1, 2, 3, 4, 5, 6. So our equation then, if area is base times height divided by 2, that would be 6 times 8 divided by 2. 6 times 8 is 48, divided by 2 is 24. There are a couple other examples that we should probably look at real quickly. Triangles. So this is a point where I would pause, see if you can determine the area of this triangle when it looks a little bit different, and then come back for the answer. In this case, this I would call my base. It's a nice straight line here that I can count. 1, 2, 3, 4, 5, 6, 7 is my base. And we need to go straight up to the final point from the base. That would be our height. 1, 2, 3, 4, 5, 6, 7, 8. So, base times height, 7 times 8, divided by 2, should be 28. Final one is a little bit different. Again, I would pause, definitely take a minute to think about what makes sense to you, and then come back for that answer. In this case, our base is still our flat line here. The issue is getting the height, right? Where is the height? This is our other point up here, but how do I find that height? Because, like I said before, we need to go straight up from the base. So you could think about it just like this. Okay, so the base is this line on the bottom. We've got 1, 2, 3, 4, 5, 6, 7. And then going up, we could just go up to this same height of our point. That can be our height. So that would be 1, 2, 3, 4, 5, 6. The way that I traditionally think about it is if you were to extend the base so that you can go straight up to that point, we count it that way. So in this case, the height is still that same number, 1, 2, 3, 4, 5, 6. So the height is 6. The base was 7. 7 times 6 is 42, divided by 2 is 21. Finally, kind of putting all of this together, we can look at one last example for looking for area. So if we have a shape that's kind of misshapen like this, it's not a standard rectangle or triangle, how can we find the whole area of a shape like this? So again, good pause point, see what you can figure out, come back. So whenever we have a shape like this, we need to break it up. This is a 1, 2, 3, 4, this is a oddly shaped pentagon. It is a concave pentagon. We don't have a formula for that. We need to break this up into different pieces and then add up those pieces. If it were me, there's more than one way to do this, but I see a way that I could break this up. I've got my rectangle here, and then if I have one triangle and then a second triangle, I would break this up into those 3 shapes. So this is segment 1, segment 2, and segment 3. And we can find the area of all 3 of those segments. So area number 1 is just a big rectangle, 3 by 9. So rectangles are just length times width. So 3 times 9, 27. Area number 2 is a triangle with a base of 2 and a height of 1, 2, 3, 4, 5. So 2 times 5 divided by 2 equals 5. And then area number 3 base of 3, height of 4. So our area is 3 times 4 divided by 2. 3 times 4 is 12, divided by 2 is 6. So if we add those pieces up, add those three areas, so the area of the total would be 27 plus 5 plus 6 for a total of 38. And when we're talking about area, remember, we're talking about 38 like squares, right? We usually say 38 units squared.